Scatter plots are plotted points on a graph that usually show a correlation between two real-life variables, such as hours of study relative to test scores, or temperature versus number of zoo visitors. Once a scatter plot is put together, sometimes events can be predicted based on one variable or another. This is an example of a scatter plot. Each point represents an event, namely the high temperature for the day and the number of visitors that frequent the zoo on that day. If you notice, the plots are scattered. However, they loosely follow a line. This is called a correlation, meaning that one factor appears to influence the other. There are different types of correlations. A scatter plot can show a positive correlation or a negative correlation, and each of these can be a high or low correlation. A scatter plot can also show no correlation. A positive correlation is shown when the points seem to follow a line that has a positive slope. In a negative correlation, the points will trend along a line with a negative slope. If points in either seem to be loosely packed but still seem to follow a line, this is called a low correlation. This specific scatter plot would be a loose positive correlation. If points are very tight and follow very close to a line, it is a high correlation. This specific scatter plot would be a high positive correlation. Sometimes points seem to be randomly placed on a graph, which indicates that there is no correlation at all. Some variables may create graphs with clusters, which are points that are grouped together. If points are clustered, or if a correlation is high, you may also notice outliers. An outlier is a point that is farther away from most of the other data points in a set. It is most obvious accompanying clusters and high correlations, but it can also exist on graphs with low correlations. Using the correlation that you notice often involves drawing a line among the points called a line of best fit. This is a line that will roughly run straight along the middle of the grouping, attempting to show the positive or negative trend. The line is an approximation. It is often helpful to pick 2 points that you think would be along the line of best fit, and use them to draw the line. After drawing a line of best fit, data can be used to make predictions. The first step is to find the equation that best represents the line in slope-intercept form, y equals mx plus b, in which b is the y-intercept and m is the slope, or rise over run. In this example, the y-intercept is 20 and the slope is about 60 visitors for every 40 degrees, which is 60 over 40, or 3 over 2. So the equation for this graph is y equals 3 over 2 times x plus 20, in which y is the number of visitors and x is the temperature. Once you have an equation, you can use it to make predictions regarding how the variables will affect each other. For example, suppose a zoo needed to order a number of handouts for visitors and needed an idea of how many to make. Considering this correlation, they could insert the high temperature of 72 degrees Fahrenheit for x in the equation. Solving for the remaining variable will give them a good estimate of how many people will come that day based upon how warm it is going to be, as long as the temperature stays within the range in the graph. On a 72-degree day, the zoo should make at least 128 handouts. If you look at the graph, you can see that the line coincides with the same data. Scatter plots are very useful in drawing correlations between 2 variables. While correlations do not always mean that a change in one variable is the cause of the change in another, it is a very helpful tool to help predict an outcome when little information is available.